Lesson 37 is on work and energy. And these are important terms in physics, and they're probably not what you think. They're very specific in physics, work and energy. And before we go through this lesson, you might want to go to YouTube and watch this video. It's the world's most asked questions. What is energy? And this is Hank Green. I really enjoy his video. So watch that video and then come back to the lesson. And the lesson starts with two definitions for work. So work can be a transfer of energy, and the example in your notes is very good. It says somebody's running up the stairs, the chemical energy is converted in your muscles is converted to kinetic energy, and as you gain elevation, you are gaining gravitational potential energy, and then if you fall, that gravitational potential energy, it becomes kinetic energy. So the transfer of energy. The second definition, the one that you're probably more concerned with for Physics 20, is work happens when a force causes an object to move through a displacement. So if this is the ground, and you have a book on the ground, and you grab that book and you lift it up, so now the book is up here, that you have done work to move the book up, and it has now gained gravitational potential energy. Gravitational potential energy. So you can see it ties in with definition 1. Gravitational potential energy. All right, and you've moved the book through a displacement. So it has changed location. It's in a different location than it started with. You've done work to make that happen because now this book has gravitational potential energy. So let's look through these examples. And again, they might trip you up a little bit. First one says, I'm holding a 2-kilogram block of cheese in my hands. I walk 12 meters to the other side of the room. Explain if I did any work. So here you are. Here's the cheese. You walk 12 meters this way. And it says, explain if I did any work. And what it really should do is explain if it did any work on the cheese. On the cheese. Did I do any work on the cheese? And the answer to that question is no, I didn't do any work on that cheese, because the displacement of the cheese at this point here has gravitational potential energy. We're going to call that EP. And over here, oh, the cheese disappeared. It's back. And over here, the cheese has the same amounts of gravitational potential energy. So the answer to that question is no, I did not do any work on the cheese, because the displacement of the cheese is 0. Yes, it moved horizontally, but it hasn't gained any energy. It has the same amount of gravitational potential energy as it did before I moved 12 meters. Number 2 says, I decided to get my pet frog to do a little weightlifting. He lifts 10 kilograms up from the floor over his head and back down to the floor. Explain if he did any work. And you're probably intuitively going to say, yes, of course he did work. If you lift weights, if you're bench pressing a weight and you're lifting it up and down, you feel like you're doing a lot of work. But the answer in physics terms is no, he didn't do any work. Why didn't he do any work? Because he lifted here's the weight. Here's the weight. He lifted it up and he lifted it down again. So what is the displacement of the weight? The displacement is 0. Therefore, he did not do any work. Number 3. Last winter, my car got caught in a snowbank. I promised one of my friends if he comes over to do some work for me, I'll buy him a Whopper. We get behind the car and push it out of the snow. Explain if we did any work. So here's the car. You push it out of the snow. Did you do any work? Yes, you did. You did work in that case because you have it because you were pushing the car this way, and the displacement of the car is in this direction. So you're pushing the car in the direction, and it moves in that direction. So yes, in that case, you did do some work. What about the next one? Example number 4, I'm holding a 10-kilogram book. That's a heavy book. I put it down on the floor. Explain if we did any work. And this, again, is a 10 kind of a technical thing, because of course you feel like you're doing work if you're holding a book up and then you put it down to the ground. Of course you feel like you're doing some work, but you're not. What is actually doing work? It's the planet, gravity. Gravity is doing the work. So you're not really doing the work. You're pushing the book up as you lower it down to the ground. It's actually gravity that's doing the work. Okay, so let's get onto a formula that deals with this, and here it is here. There are two formulas here, both on your formula sheet. And the first one is really important, it's more so probably in physics 30, but that formula says that work equals delta E, which means obviously a change in energy. Change in energy. So anytime there's a change in energy, no matter what kind of energy it is kinetic energy, potential energy, gravitational potential energy, elastic potential energy, that classifies as work. The other definition is that work, or the other formula is that work equals force times distance times the cosine of theta. And where that cosine theta comes in is, for example, if you're pulling something with a handle or a lawnmower, let's say you're pushing a lawnmower. If you're pushing a lawnmower handle and you're pushing it in this direction, but the lawnmower is moving in this direction, then only the horizontal component, here's the vector that you're pushing this way, only this horizontal component is being used in the displacement, so therefore only this horizontal component is being used as part of the work. Okay, so we'll do some examples like that. And so on and so on. You can read your notes here. That just and here's an example of that. So we've got something with a handle, or it's at an angle, but the object's moving in a horizontal direction. So therefore, only the x component or whatever force this is being used to do the work. Okay, and then you can go over these notes here. It just explains why if you have a cosine of 0, in other words, let's say I've got a cart and I'm down on my knees and I push the cart this way, then the cosine here, the angle here between the force that you're pushing on is 0 degrees. And the cosine of 0 equals 1, and therefore the maximum amount, or all the force that you're using, contributes to the work. However, if you're pushing this cart at an angle like this, then some of your force is pushing it down into the ground, but it's not going down into the ground, it's still going this way. So that's where this horizontal component comes in, and this explains it here. And obviously, it says if cosine 90 equals 0, so if you're pushing, if you've got a cart here, and here's your handle, and you're pushing directly down, well, that cart is not going to move horizontally at all, and that's why the cosine of 0. So in other words, the work you're going to do in that case is going to be 0, because the cart is not going to move. Okay, and so on. Just to note, to remember this, that work has no direction, and therefore it's a scalar quantity. And on to example number 5. And number 5 says, my daughter Katrine grabs my son's Neil's leg and drags him 2.3 meters across the floor. If she exerted a force of 8.1 newtons to do this, determine how much work she did. Pretty straightforward. Plug in the numbers. And get your answer, which turns out to be 19. And what are the units for work? They are, well, theoretically, they would be newtons meters. Force is measured in newtons, distance is measured in meters, but a newton meter we're commonly going to call a joule. So work, and it comes back to this formula here that we talked about. Work equals change in energy And we should know from Science 10 that energy is always measured in joules, and therefore work is also measured in joules. Alrighty then, example number 6 says you're pulling a box at a 30-degree angle. The box moves 12.7 meters when you pull along the rope with a force of 76 newtons. Determine how much work you did. So here's your box. You're pulling on a rope. This is a 30-degree angle. And again, it is this component here that is making the box move. And therefore, we're going to use this formula. The cosine of theta, so this cosine theta will give us the x components of this. Let's just go review. Why does that give us the x components? You have a horizontal component, a vertical component, an x and a y. And if the force that I'm pulling with is right here, 76 newtons, and I want to calculate what's the x component, that would be the cosine, because x is the adjacent side and 76 is the hypotenuse. Adjacent over hypotenuse is cosine, so it'd be the cosine of 30 equals x over 76 will give us the x component there, and then we can just multiply that by the distance. So you can see here, just in this part here, you can see how to calculate x, you can get 76 times cosine 30. Well, look what happens if we do this. 76, my displacement, and there's my cosine 30 at the end. So you can see how that will give us work eventually, and that will be 836 joules of energy. And that is it for lesson 37. We'll go on to lesson 38, which is how to graph work.